Hello everybody, this is day 2 working on tangents. So we stopped here yesterday. We had this problem. Tangent to y equals 2x cubed plus k times x squared minus 3 at the point x equals 2 has gradient of 4. All right, so let's look at this. Let's get some more space to write on over here. So this is the equation of the function. We have that x equals 2, and we have that the slope of the tangent has gradient is 4. So find k. One way of finding k will be to first find the derivative of this function and set the derivative equal to 4, because the gradient, or f prime of x, or in this case just y prime, equals 4. So let's do that. So y prime equals 2x cubed. So derivative of 2x cubed is 6x squared plus a derivative of kx squared is 2kx, and then derivative of negative 3 is 0. Now we have that this right here is the derivative function, but now we're going to use the information that x equals 2. So we will plug in 2 right here for x, and then we're going to set this equal to 4. So let's go ahead and do that. So 6 plug in 2 squared plus 2k plug in 2 for x. All of that equals 4. So 6 times 2 squared is 4. 6 times 4 is 24, plus 2 times 2 is 4, k equals 4. Now we want to solve for k, so I'm going to subtract 24 from both sides. And I have the 4k equals negative 20. Now we want to solve for k, so we have to divide by 4, and we have that k is negative 5. So we have found the answer to part A. And now let's see over here. If we plug in, it says, hence find the equation of this tangent. So first, let's go ahead and plug in k in the original equation. So y equals 2 times x cubed minus 5 x squared minus 3. Over here, this will help us find the coordinate, the y coordinate of the contact point of the tangent. So we have that the x coordinate is 2. If we plug in 2, we will get the y coordinate. Remember, we need both x and y, and we need this gradient in order to find what's the equation of the tangent line. So let's go ahead and plug in 2. So y equals 2, substitute 2 for x cubed minus 5, substitute 2 for x minus 3. So 2 cubed is 8 times 2, that's 16, minus 5 times 2 squared, that's minus 20, and then minus 3. So this is going to be 16 minus 20 is negative 4 minus 3, negative 7. So our y coordinate is negative 7. Okay, now that we have x and y and we have the gradient, we are ready to write down the equation of the tangent line. So here it is. So y equals, we first use the gradient for x minus our value right here, 2, and then plus whatever the y coordinate is, so negative 7. And then now let's go ahead and simplify this. So this is going to be 4x minus 8. 4 times negative 2 is negative 8, plus negative 7, so that's minus 7. So I have my final answer is y equals 4x minus 15 is the equation of a tangent line. So we have a couple of different types of problems here, so that I want to look at. I want to definitely look at this example. Before we get to the example, let's look at number 5. It says find the equation of another tangent to this curve, which is parallel to the tangent at 1, 2. anytime two lines are parallel, that means that their slopes or gradients are the same. So if we're asked to find the gradient, first thought that comes to mind is take the derivative. So let's do it. Y prime equals, so derivative of this y is going to be just -3 plus 24x and then minus 24x squared. So that's the derivative. Now we want to evaluate it at x equals 1. So at x equals 1, we want to see what's the actual value. So y prime equals -3 plus 24, substitute 1 for x, minus 24, substitute 1 again for x. So this is going to be, so what do we have? This is -3 plus 24, and this is minus 24, so it's just going to be -3. So y prime is -3. Okay. So now it says find the equation of another tangent to this line. So if I set this up, -3 plus 24x minus 24x squared equals -3. I'm going to look at, I need to really solve for x right now. So I'm setting this derivative equal to -3 because the other line has the same slope or the same gradient, but we don't know at what point, what is the contact point of that tangent parallel to the first tangent. So let's go ahead and solve this. So first thing that I'm going to do is add 3 to both sides. And then I have over here 24x minus 24x squared. What I can do is I can factor out 24x, and I have 1 minus x. And all of that equals 0. Okay? So how did we factor this? We noticed that 24 and 24 can be factored out. That's the common factor, greatest common factor. And then x and x squared, we can factor out x. And then remember, that's factoring out GCF, which means go back and divide each term by the GCF, greatest common factor. Now, to solve this equation, we are going to use the zero product property, which says if you have a product of two numbers is 0, that means that at least one of the numbers is 0. So either 24x equals 0 or 1 minus x equals 0. So solve for this means that x would be 0. And then if I solve for this, it will be, so subtract 1. So that's -x equals -1. And then divide by -1. Both sides, I have that x is 1. So we already had this situation that x was 1. This is this point. So my second point has the x coordinate 0. The second point to which that has the parallel tangent. All I need to do is find what y is. So if I plug in x equals 0 into the original equation, I will get that. So I substitute 0 here, 0 here, and 0 here. All of these terms will become 0. So I immediately see that my y is 1. So what's the point? The point is 0, 1. That's the contact point of the second tangent. And now let's go ahead and write the final equation. The final equation will be y equals, so first I'm going to put the gradient, which is -3, times x minus 0, which is my x coordinate, and then plus 1, okay? Plus 1 because my y is 1. So I have over here, distribute, -3x. This is just 0, and then plus 1. So this is the equation. We found the equation of another tangent that's parallel to the given tangent line at 1, 2. I want to also go over this example. Consider the curve, given curve x cubed minus 4x squared minus 6x plus 8. Find the equation of the tangent line to this curve at the point where x equals 0, and then at what point does this tangent meet the curve again. So we are going to first find the equation of the tangent. What does that mean? We first need the derivative, y prime, and then second, we need the contact point. So we know that x coordinate is 0. We will just need to find y by plugging in 0 here. And let's just go ahead and do that. If I substitute 0 for each x, I have that y is 8. So I don't even have to calculate that. It's obvious. Now let's find the derivative of this function. So it's going to be 3x squared minus 8x and then minus 6. To evaluate the derivative at x equals 0, so at x equals 0, we're going to substitute zeros for x. So it will be y prime equals, when I substitute 0 right here for x, I see that my derivative is negative 6. So now I have all the information that I need to write the equation. Here's the equation. Y equals, first the derivative, negative 6, or the gradient, x minus 0 plus 8, distribute, so it's negative 6x plus 8. So this would be the equation. Okay, how do you find the answer to this question? So I'm going to need you to use your graphing calculator for this, TI-84. So we're going to use technology. Okay, so TI-84, and you're going to go to y equals first, and you're going to graph the first function, x cubed minus 4x squared. So y1 will be this, the original function, and y2 will be your tangent line, equation of the tangent line, so negative 6x plus 8. So then once you graph this, then you will go to second trace and then find the intersection. And this will provide for you where the lines intersect. This will be the answer right here. And so go ahead and try to do that on your calculator and check the answer keys on Schoology. Thank you for watching.